public health researchers and epidemiological analysts are currently examining new mathematical projections that suggest a potential shift in the transmission patterns of Hantavirus, a zoonotic pathogen traditionally associated with specific environmental niches. While recent headlines have highlighted concerns regarding viral spread within the confined environments of cruise ships, these latest models indicate that the risk profile may be expanding into broader geographical and social contexts. To understand the gravity of these projections, it is necessary to examine the nature of Hantavirus itself. This family of viruses is primarily carried by rodents, specifically certain species of mice and rats, which serve as natural reservoirs. Unlike many common respiratory illnesses, Hantavirus is not typically known for sustained human-to-human transmission, but rather for its spillover from animal populations to humans. The concern among health officials stems from the severity of the diseases these viruses cause, including hantavirus pulmonary syndrome in the Americas and hemorrhagic fever with Raynaud syndrome in Europe and Asia. The current framing of the situation focuses on how predictive modeling can identify new hotspots where human-rodent interactions are increasing. By analyzing variables such as climate shifts, changes in rodent population density, and human migration or travel patterns, scientists are attempting to get ahead of the curve. The mention of cruise ships in recent reporting serves as a critical case study in how viruses behave in high-density, enclosed spaces, providing a controlled environment for data collection that is now being applied to larger, more complex urban and rural landscapes. This transition from localized concern to a broader public health outlook underscores the necessity of robust surveillance systems. Viewers and the general public should take note not because a mass outbreak is necessarily imminent, but because the mechanisms of viral spread are changing in ways that require updated prevention strategies and heightened awareness among clinical providers and travelers alike. The core of the current reporting revolves around the development of sophisticated diagnostic and monitoring frameworks managed by national health agencies and international laboratories. In response to the data generated by mathematical models, public health departments are intensifying their surveillance of rodent reservoirs. This involves field teams collecting biological samples from local rodent populations to test for viral prevalence, a process that allows labs to map out the specific strains present in a given area. When a model predicts a spread beyond previous boundaries, such as from maritime environments to inland urban centers, it triggers a series of actions within the clinical community. Hospitals and clinics are being advised to look for specific clusters of symptoms that might otherwise be mistaken for more common respiratory or renal ailments. The diagnostic process itself is complex, often requiring specialized enzyme-linked immunosorbent assays, or ELISA, to detect hantavirus-specific antibodies, or polymerase chain reaction, or PCR, tests to identify the viral genetic material in patient samples. There is a clear distinction between the verified data provided by these laboratory results and the speculative claims often found in sensationalized reports. While models use phrases like terrifying spread, health officials focus on the R0 values and the specific environmental triggers that lead to increased human exposure. Shipping and logistics industries are also under scrutiny, as the movement of goods provides potential pathways for rodent stowaways to enter new regions. However, it is important to note that most agencies report that the risk in these sectors remains manageable through standard integrated pest management protocols. The current discourse emphasizes the importance of transparency, where official statements from organizations like the Centers for Disease Control or the World Health Organization provide a grounded contrast to the more alarmist projections. These agencies stress that while the models are essential for preparation, they are based on probabilities rather than certainties, and their primary value lies in directing resources to where they are most likely to be needed for early detection and containment. Prevention and long-term surveillance remain the primary tools for mitigating the risks identified in recent epidemiological models. Public health guidance continues to focus on the elimination of rodent habitats in and around human dwellings and workplaces. This involves practical steps such as sealing entry points in buildings, using professional pest control services, and ensuring that food sources are not accessible to mice or rats. A critical component of prevention is the safe cleaning of areas where rodents may have been present. Because hantavirus is often transmitted through the inhalation of aerosolized particles from rodent excreta, officials warn against dry sweeping or vacuuming in infested areas. Instead, the use of disinfectants and wet cleaning methods is recommended to keep dust from becoming airborne. Beyond individual actions, the limits of current scientific knowledge must be acknowledged. While mathematical models have become significantly more accurate, predicting the exact timing and location of a zoonotic spillover remains a challenge. There are still many unknowns regarding why certain individuals develop more severe symptoms than others, and how long-term environmental changes will continue to influence the behavior of reservoir species. Surveillance programs are working to close these gaps by integrating satellite imagery and ecological data into their predictive frameworks. The goal is to move from a reactive stance to a proactive one, where public health alerts can be issued before human cases even occur. As we monitor these developments, the emphasis remains on calm, evidence-based preparation rather than panic. Public health officials suggest that staying informed through official channels is the best way to navigate the evolving landscape of infectious disease. Continued investment in laboratory infrastructure and field research is essential to ensure that the terrifying projections of today do not become the reality of tomorrow. For more updates on global health reporting and surveillance developments, consider following this channel for factual coverage. The core developments in hantavirus surveillance and response involve a complex coordination between national health agencies, specialized reference laboratories, and maritime transport authorities, as mathematical models suggest a potential expansion of the virus beyond previously identified clusters. Such as those associated with cruise ships, public health officials are focusing on the mechanics of zoonotic spillover and the specific diagnostic protocols required to confirm cases. In the laboratory setting, the identification of hantavirus is a rigorous process. Because the virus is typically classified under biosafety level 3 or 4 conditions depending on the strain, diagnostic testing is concentrated in high-containment facilities. Clinical confirmation primarily relies on molecular assays, such as reverse transcription polymerase chain reaction, or RT-PCR, to detect viral RNA in blood or tissue samples. Serological testing is also critical, utilizing enzyme-linked immunosorbent assays to identify the presence of hantavirus-specific IgM and IgG antibodies. These tests allow clinicians to differentiate hantavirus from more common respiratory or febrile illnesses, such as influenza or leptospirosis, which often present with similar initial symptoms, including fever, myalgia, and headache. The mention of cruise ships in recent data highlights a specific concern regarding confined environments and the logistics of global trade. Maritime health protocols are being scrutinized to ensure that rodent control measures are strictly enforced on vessels that move between international ports. While the source material notes the potential for spread beyond these ships, health agencies emphasize that the primary risk factor remains the presence of infected rodent reservoirs, such as the deer mouse in North America or the brown rat in urban environments worldwide. This transition from maritime to terrestrial concerns involves tracking shipping containers and warehouse logistics, where rodents may find harborage. In hospitals, the clinical focus is on the prodromal phase of the illness. For hantavirus pulmonary syndrome, or HPS, this often leads to rapid respiratory failure, requiring intensive care interventions such as supplemental oxygen or, in severe instances, extracorporeal membrane oxygenation, known as ECMO. For hemorrhagic fever with renal syndrome, or HFRS, common in parts of Europe and Asia, the focus shifts to monitoring renal function and managing potential hemorrhaging. Official statements from health departments contrast the sensationalized, terrifying spread with the reality that human-to-human transmission remains an extremely rare event, documented almost exclusively with the Andes virus strain in South America. Most agencies maintain that while the models are useful for identifying high-risk areas based on ecological shifts, the actual risk to the general public is mitigated by standard public health infrastructure. This infrastructure includes sentinel surveillance programs that monitor rodent populations for viral prevalence before human cases are even reported. By integrating environmental data, such as rainfall patterns that increase rodent food supplies, with clinical data, agencies attempt to create a comprehensive early warning system. The verification of these models depends on ground truth data from clinics and labs, ensuring that public health responses are based on confirmed viral activity rather than theoretical projections alone. Trade and travel sectors are advised to maintain rigorous sanitation standards, as the movement of goods provides the primary pathway for the introduction of reservoir species into new geographic regions, a factor that these new mathematical models are designed to track with increasing precision. The transition from predictive modeling to active prevention requires a grounded understanding of how hantavirus interacts with human environments. Public health guidance remains the most effective tool in mitigating the risks identified by these new mathematical projections. The primary directive from health authorities is the systematic reduction of rodent-to-human contact, a strategy often referred to as rodent-proofing. This involves a dual approach of exclusion and sanitation. Property owners and facility managers are advised to seal all potential entry points into buildings, noting that mice can enter through gaps as small as a quarter inch, or roughly the size of a pencil eraser. Use of metal flashing, cement, or heavy-duty wire mesh is recommended over materials like plastic or wood, which rodents can easily penetrate. Beyond structural integrity, the elimination of food sources including improperly stored grain, pet food, and refuse is critical to preventing the establishment of nesting colonies near human habitation. A vital component of public safety involves the correct procedure for cleaning areas where rodent activity has been detected. Health officials emphasize that the most dangerous aspect of hantavirus is the potential for aerosolization. When dried rodent urine, droppings, or nesting materials are disturbed, the virus can become airborne in microscopic particles that are easily inhaled. Consequently, the use of vacuum cleaners or dry sweeping is strictly discouraged in these environments, as these actions actively facilitate the spread of the virus into the air. Instead, a wet cleaning protocol is mandated. This involves saturating the affected area with a disinfectant, most commonly a solution of 1 part chlorine bleach to 9 parts water, for at least 5 minutes before wiping the area down with paper towels or rags. This chemical intervention effectively deactivates the virus's lipid envelope, rendering it non-infectious. Protective equipment, including rubber or nitrile gloves and high-efficiency particulate air, or HEPA, filtered masks, provides a necessary barrier for those performing these tasks in enclosed or poorly ventilated spaces. The broader surveillance strategy, often categorized under the One Health framework, seeks to bridge the gap between ecological changes and human health outcomes. This involves continuous monitoring of climate variables, such as unseasonably high rainfall or mild winters, which can lead to a mast year, a period of high seed production that fuels rapid rodent population growth. By tracking these ecological markers, public health agencies can issue localized warnings before a single human case is reported. However, the limits of current scientific knowledge must be addressed with transparency. While mathematical models can highlight statistical probabilities of spread beyond cruise ships or traditional rural boundaries, they cannot predict the exact moment of a spillover event. There is also the persistent challenge of vaccine development. While vaccines for hemorrhagic fever with Renal syndrome are utilized in some regions of Asia, there is currently no widely available vaccine for hantavirus pulmonary syndrome in the Western Hemisphere. Leaving prevention and early clinical intervention as the only viable lines of defense, ethically, the reporting of these terrifying projections carries a significant responsibility. The goal of public health communication is to foster vigilance without inciting panic. While the data suggests an evolving risk landscape, the actual incidence of hantavirus remains statistically low compared to other infectious diseases. The uncertainty inherent in predictive modeling should be viewed not as a cause for alarm, but as a roadmap for targeted research and infrastructure reinforcement. The duty of health officials and news editors alike is to provide the public with the tools for self-protection while maintaining a rigorous commitment to verify data. By focusing on practical takeaways, such as environmental management and early symptom recognition, society can effectively manage the intersection of human expansion and zoonotic reservoirs. As the science of epidemiology continues to refine its predictive capabilities, the core of the response remains constant, a reliance on hygiene, surveillance, and the transparent dissemination of laboratory findings. For continued coverage of